2 of 75-day coding challenge, and today we are going to solve our second problem statement, greatest common divisor of a string. So yeah, let's start. For two string s and t, we say t divide s if and only if s is equal to n time of t. We say t divide s if and only if s is equal to concatenation of t. Given two string str1 and str2, return the largest string x such that x divide both str1 and str2. S1 is equal to ABC, 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 and ABC, and S2 is equal to ABC, ABC. What is the common divisor between both strings? Let's call it X. So I can say it is ABC, right? ABC because concatenating 2 time of ABC, it make S2, and concatenating 3 time of ABC make it S1, right? So X is the greatest common divisor. Let's take another example. S1 is AB, AB, and AB, and S2 is AB and AB. So for this, the greatest common divisor is AB. Same logic, like if you concatenate AB one time, it become AB and AB, and if we concatenate 2 times, it become S1. So concatenating X, our GCD is AB, and 2X make 3X make S1, and 2X make S2. And for our third test case, leet and code, there is no common divisor. As you can clearly see, there is no substring that we can concatenate with itself to make str1 or str2. Correct. So let's try to solve this problem mathematically. We can say for if we consider this case, that let's write it in this way: s1 plus s2 equal to s2 plus s1. So S1 is ABC, ABC, and ABC, plus S2 is ABC and ABC. Similarly, S2 is ABC, ABC, and S1 is ABC, ABC, ABC. So S1 I can also write as an 3x, and S2 I can write as an 2x. Similarly, S2 as an 2x, 2x plus 3x. So 5x is equal to 5x. So we have just proved that if S1 plus S2 is equal to S2 plus S1, then GCD exists. Else, return empty. This is our first condition to check if the GCD exists or not. So for this third test case, we can see there is no greatest common divisor. We will concatenate str1 plus str2. So it will make something like leet code equal to code leet, right? And it is not equal, so we will simply return empty for these cases. So these are this is the first condition that we need to check. By passing this condition, we are assured that GCD exists. So if GCD exists, now let's formulate our second logic. If suppose the length of S1 is 6 and length of S2 is 12. So what is the greatest common divisor between 6 and 12 number? It is 6, right? But what is the all common divisor between 6 and 12? It is 1 and uh, 2 and 3 and 6, right? So by concatenating one character again and again, we can make 6. Basically 6 into 1, basically 6 divisible by 1 and by 12 also. Similarly 2, 3 and 6. These are the all the possible value of GCD, but this 6 is the GCD, the greatest common divisor in all of them. Let's try this same mathematical way to solve our this problem statement of a string. If the length of S1 is 6 and length of S2 is 12, you can argue the greatest common divisor can be 1 or 3 or 6, but it cannot be more than 6, correct? But if I say ki it is 1, basically then we are saying ki we are concatenating a single character 6 times and we are concatenating single character by 12 times. So if we are concatenating single character, we can also say I can take 3, right? Because by concatenating 3 2 times, I can make 6. And by concatenating 3 4 times, I can make 12. So basically concatenating 3 2 times make us S1 and concatenating 3 4 times making it S2. Correct. But I can also argue why not take 6. So basically concatenating taking S1 as an GCD as an 6, but we can concatenate, we do not need to concatenate to form S1, but we can concatenate 6 2 times. So 6 is already S1, and by concatenating 6 2 times, I can say forming S2. Correct. So one case is 3. 3 can be a greatest common divisor, but a substring 3 it it already exists, and it is the and it is already a common divisor of 6. So if 3 is a common divisor, then 6 is also a common divisor, right? Because we are just concatenating 3 2 times to form S1. So if the 3 is the common divisor of 6, then if 3 is a divisor of 6, then 6 will also be a divisor of 6. Correct? And if we concatenate 6 2 times, it becomes S2. 6 is the greatest common divisor, always. And if we take another case, if length of S1 is 6 and length of S2 is 9, then the greatest common divisor, what is the possible greatest common divisor that can exist of length 1 or length 3, right? And so if we concatenate 1 6 times, it make S1. But I can argue why not, if 1 is a possible case, then 3 will obviously will be the common divisor, right? Because if we just concatenate 3 2 times, it will make 6, right? So by checking this logic, we can write the logic that in the first condition, we know that GCD exists. But if GCD exists, the second condition will be if length of S2 or S1 is divisible by length of S1, if length of S2 or S1, whatever is greater, is divisible by the S1. So in this case, we are saying S2 have the more length. If divisible by S1, then length of S1 is the answer. Length of S1 is the answer blindly if it is divisible. Else, if it is not divisible, if length of S2 is not divisible by S1, we say find the GCD of length of S2, comma S1. So this is the second equation. And simply we can also say, like if the GCD exists, simply return the answer of GCD of both length of S1, comma S2. Whatever is length, just find the GCD for it. Because for 6 and 12 case also, the greatest common divisor is 6. For 6 and 9 case also, the greatest common divisor is 3. So simply just find the greatest common divisor. So we do not need this condition. I just write it to explain it to you. So if the first condition passed, there is a GCD exists, we simply need to find the GCD of two string, and this will be the answer. So you can find, you can write some example test cases of your and try to execute both this mathematical equation on them, and you will find it we are always able to find the GCD. So let's jump to the coding part for now. So our first condition, first we need to execute is if S1 is a S2, if S1 plus S2 is equal to S2 plus S1. So str1 dot length, uh, sorry, str1 plus str2 should be equal to str2 plus str1. If this is not equal, we simply say return empty. There is no GCD exist. Now let's implement our GCD part. If GCD exists, we need to find the GCD of the both length. So I'm writing GCD function private static int GCD int m length of string 1 or and length of string 2. We can say it x and y. If y is equal to 0, return x, call GCD by y comma x modulus y. This is the standard GCD function to find between two number. GCD to find between two number. Let's call our uh, I call our answer int GCD equal to GCD between str1 dot length and str2 dot length and str. You can use str1 or str2 any string to find the substring because GCD exists in both the string. So you can use str1 or str2 here, and we are saying 0 comma our GCD length. So if we pass 9 and 12 here, the GCD will come as 3. So basically, it will just substring the first three character 0 to 3, right? So yeah, let's run our test case if it is working. Yeah, we have written something. Let's delete this part. Comment it for now. Str. Okay, our all test cases is passed successfully. Let's submit our problem statement. And yeah, it got submitted. So yeah, thanks for seeing the session. Let's meet tomorrow.